let me finish these thin mints, and then we'll talk about the 4-4 ready, set, go. All right, I think I did. That's good. Love the Girl Scout cookie season. All right, the ready has you finding roots and domain for each function. This is just a polynomial, really, of degree 3, which would start low, go up, do something like that probably. This is going to produce roots at the following values. Opposite of this 5 would be -5. Opposite of -2 is +2. Opposite of -7 is +7. For the domain, it's actually all real. Why is that? This isn't like a rational expression where there are going to be some vertical asymptotes we have to acknowledge. So this one isn't too bad. Let's look here. This is factorable to x plus 1 and x plus 6. So your roots are the opposite of +1 and +6. So -1, -6. And your domain is all real. Again, because this is just a upwards parabola, any x value will give you some outcome. However, down here, we don't really have roots for this type of situation. It's not really talked about with rational expressions. It's more so with polynomials. So here, the domain does switch up because now we say that the domain's all real with the exception of how x shouldn't be equal to pretty much these roots, -5 and 2 and 7. And so take a moment. What do you think the domain would be for problem 4? Still all real numbers, but with x not being able to equal -1 or -6. So do the roots of the polynomials in problems 1 and 2 tell you anything about the graph of the reciprocal of the polynomial represented in k of x and h of x? Yes, because what was previously going to be the roots have now transitioned into being the vertical, you guessed it, asymptotes. So it does kind of help us figure out what the domain's going to be respectively. Okay, capiche? Does that make sense? I'll leave 6 and 7 to you. What are we doing here? We're finding the degree, right? Degree of the numerator and the denominator, light work. All right. Luckily, these are all, for the most part, multiplicities of 1, and they're all in that factored convenient form. So if you were to FOIL all this out, you end up with an x cubed term up top, some other stuff, and you would have x squared down here, and some other stuff. So here, the top degree is 3, bottom degree is 2. Pretty simple. If this all FOILed out, you would get an x squared term, and it would be 5x squared for what it's worth, and some other stuff. And then this would be 3x squared plus 9x. This one's not too bad. So both would be degree 2s. And let me ask, what do you think the vertical asymptote would be? That would occur where, horizontal asymptote. That would occur where y equals 5/3. Not asked of us, but that's the kind of thinking you should be building into now. I'll give you a moment to try problem 10. Let's take a look at what the top degree is, what's the bottom degree, and we'll go from there. We're back. Top degree is 2, bottom degree is 4. There you go. Which function in problems 8 through 10 has a horizontal asymptote at y equals 0? That occurs when the bottom is greater than the top. So the only option that has that happen is problem 10. So which problem is it? Problem 10. It's interesting. I kind of nodded at the horizontal asymptote there, but didn't know I had to bring it up until problem 11. Classic. Write the equation of the vertical asymptote indicate the graph as a whole in it instead of vertical asymptote. This is screaming classwork ideas at us. So we're going to approach it the same way. I don't know, dealer's choice. What do I want to do? I'm going to take an easier route. I'm going to factor this because I'm just thinking, you know, factors of -8 that add up to 2. It's got to be 4 and -2. So the top part's x plus 4 times x minus 2. Bottom's difference of squares, so x plus 4, x minus 4. So right here, this is screaming that there's going to be a hole at -4 because the opposite of this 4 is -4. So instead of having a vertical asymptote there, we'll have a hole instead. And that hole is going to be at this situation, x minus 2 over x minus 4. And if we want to find that y coordinate, we could plug in there, which I think is going to kick back -6 over -8, which is just positive 3/4. So we do have that hole. And we don't really need this point now because we've upgraded. So we have a hole there, and we have a vertical asymptote at what's left over, which in this case, is going to be where x equals 4. So notice the hole was produced because one of our factors was able to be canceled in the mathematical sense, of course. And so that produced a, you know, what would be a vertical asymptote, but we have to plug in and like figure out where. I plug in and figure out where the y coordinate should be because I think that's just good practice and it's not too tough. So yeah, there you go. This is a difference of squares up here. This is a binomial being squared. If you're not convinced, try it. What's this? 6x minus 7, 6x plus 7. So this doesn't have any holes, but it does have a vertical asymptote where x equals 7. Capiche? I'll leave problem 12 to you to find. Use long division to get the slant asymptote. Oh, light work. Luckily, we can use synthetic division for 15 and 16. And this is all because it's x minus or x plus some root, or in this case, vertical asymptote. So I'll do that for problem 15 first. So I'm taking the root of the denominator, or what would be the vertical asymptote. I'm using my coefficients respectively. Drop the 2 like it's hot. 1 times 2 is 2. 3 plus 2 is 5. 1 times 5 is 5. 4 plus 5 is 9. So the slant asymptote is just built around this. So it's going to be 2x plus 5. That'll be the slant asymptote. We could write out the, yeah, I guess they do want me to write all that. Okay, easy enough. So we could say that this is 2x plus 5 plus remainder 9 over x minus 1. And then the slant asymptote is here. Do you want to take a moment to try 16? Take a moment, pause the video, try 16, see if you can get the quotient with the remainder as a fraction, and then also what's the slant asymptote going to be. Hopefully you got something like this for 16. It should work. There's the slant asymptote where y equals x plus 1, and then this would be the quotient and remainder of -1 respectively. Okay, capiche? 17 I'll leave for you. You're definitely going to have to use long division here. I guess you could say I'm being lazy, but I want you to, you know, try it out, see what you get. What else to go? State the domain, write the equation of the vertical asymptote, sketch in the vertical asymptote, open circle where it's undefined. Okay, so we have a vertical asymptote definitely here. where x is -5. Notice how I just kind of jump right in and say, oh, it's this, because like visually it is that. And it would make sense because this is here. And then if you simplify this, what would that simplify to? Hopefully you're saying 1 over x plus 5. So that means that there's definitely going to be a hole where x is 2. And so there's definitely a hole when x is 2. You can see from here that it's going to be here. And I guess just for closure, this would be a y-coordinate of 1/7. If x was 2, plug in. 2 plus 5 is 7. 1 divided by that. All right. What else do they need? Is that it? I guess we should talk about where it can't equal. So our domain's all real, with the exception of how x shouldn't be equal to 2 or -5. And the graph shows that respectively. Pretty good problem. Domain, it's going to deal with these, look at these, can't be equal to those roots. So still all real, but x shouldn't equal 4 or -6. We're lucky enough to have a vertical asymptote where x is 4. So that means that we have a root or a hole where x is -6. So down here. And so if we needed that hole, that again occurs where x is -6. If you plug in respectively, that's going to kick back -1/10. And again, I'm getting this because if you simplify this, that cancels, and you get 1 over -6 minus 4, which is 1 over -10, which is just -1/10. So that's how I'm getting this. I hope that this was helpful. If you have any questions, reach out. Take care. Be safe.